All right, so we're going to talk about campus bridging. What is campus bridging, and what is XSEDE doing to get involved with campus bridging? And here's an overview of some of the people involved in campus bridging currently. Jim Ferguson, Ian Foster, Andrew Grimshaw are contributing a lot of effort on, well, Ian Foster and Andrew Grimshaw are contributing a lot of effort on sort of the architecture and design pieces. Jim Ferguson helps us out with outreach. Victor Hazelwood down there in the left-hand corner is the operations manager for XSEDE, and he's helping us get started on working on the actual systems. There's some guy in a green shirt, and Dave Lifka is the chair of the architecture team, helping folks develop the use cases and level 3 decomposition of requirements that'll be turned into software for campus bridging. Awesome. So the beginning of campus bridging really started when the National Science Foundation formed a number of task forces, each one designed to identify a specific area of computing that the NSF wanted to promote or otherwise get information from the research community and make some progress with and figure out what was needed, what could be supplied. So the general idea behind campus bridging is that if you're a researcher, you want to make use of some national cyber infrastructure resource, you apply for an account and you get an account. You go ahead and you go log in. And for a lot of people who are able to access these services, the feeling is sort of, well, now what? You know, once you've logged into the system, what do? There's the gap between, for most researchers, what they're able to do in their lab, on their desktop or workstation, and what the capability of a national cyber infrastructure resource is that's provided by XSEDE. So campus bridging is really designed to provide a bridge over that gap so that resources that are provided by XSEDE, regional resources, or even campus resources are basically proximate to, similar to the ones that are proximate to what a researcher would use. It looks like something you would just plug into your laptop and compute with. And we want to create, essentially we want to create a virtual organization that makes that, the virtual part, the part that removes everything from far away from you is irrelevant, and you just see something as kind of seamlessly integrated. That you're able to transition your analyses from your lab, your workstation, up into a campus resource or to a regional resource to participate with collaborators or to a national resource. And that transition should be really, really easy and simple. We got a lot of work cut out for us. So Craig Stewart and Guy Alms were chairs of this task force for campus bridging. They collected a large amount of responses in a survey and did a workshop to create this task force report on campus bridging. You can access the task force report at pti.iu.edu campus bridging. It provides an overview of a number of big recommendations for both the NSF to do, for campuses to do, and for vendors and sort of the industry to provide. And I think it gives a sort of a beginning direction of what can be done to support campus bridging. As part of this, Vaughn and Melinda and Craig gathered some information about capability that's available. And you can see that capability is really kind of well distributed. There's the track 1 resources that get all the headlines and are big and very important, but it's also sort of evenly smushed around across big labs, little labs, campuses, regional infrastructure. So there's a lot of capability in all these different areas, and it kind of makes sense to create a way to transition easily between these. So the task force report came up with a number of recommendations that state that the cyber infrastructure is not currently adequate. The analysis that researchers need to run require more capability than what we currently have. But it's also not utilized as well as it could be. So there's certainly resources out there that aren't getting the utilization that they could have. And a lot of the problems with that are barriers to getting into a resource, or barriers to getting your code to run, or barriers to getting your data to the correct resource. And so the requirement is to really figure out a good way to get your stuff to the place where you can do the best work. And we decided that really we're going to have to work against sort of perfectionism and find good ways to get people moving around now, and work out the bugs and improve on systems as we go, rather than create a great framework that would allow you to install something right there on your workstation that is exactly the same as a track one resource. And we just can't. That's just not something we can do. And it's not really practical and doesn't really scale. But there are some short-term things that we can do to make it a lot easier. So what XSEDE has attempted to do is really not create something like a campus bridging stack, or create campus bridging resources. What XSEDE is really trying to do is incorporate campus bridging as a mindset, and understand that through a number of its internal processes. So the architecture and design group is looking at campus bridging, the software development group is looking at campus bridging, the operations team is looking at campus bridging. All of these different teams are trying to incorporate requirements from the campus bridging team, and the campus bridging team is gathering requirements of campuses at different universities, at regional institutions, at folks who are getting involved in XSEDE for the first time, to understand what actually constitutes that gap. So we sort of work with a lot of the existing XSEDE teams to bring requirements in and get some information to folks on how things could be a little bit better done. And really what we're trying to do is address, the first task is to address data movement and getting data around. And later on we'll probably look at the HPC and the high throughput side. But the main concern for a lot of the researchers that we talk at campuses, folks who have not been involved in XSEDE previously but are interested in scaling up, is that it's just they don't know how to move their data around. They don't know how to get stuff from here to there to where they can analyze things. So what we want to do is really just look at an incremental approach, figure out how we can make things better for folks in the short term, get them started, and figure out how we can scale that up for more and more users. So the approach for campus bridging is really kind of interesting, because we're not really just looking at user services. We're also looking at ways for local system administrators to integrate their systems with XSEDE. It's kind of a two-way street. We want to make it so that the resources, the traditional XSEDE, high throughput, high performance resources are accessible to users. But we also want to make it so that a local system administrator can create a system that looks similar to an XSEDE resource to build on the best practices and the things that system administrators working for XSEDE have learned over the years, and incorporate those into their local system. So a local system will look more and more like an XSEDE resource. An XSEDE resource will look easier and easier to use for a general user. And so XSEDE has this idea of these service providers. And the level 1 service providers are the funded centers that run your big systems. And as it sort of goes down from level 1, level 2, level 3, you get sort of broader and broader interpretation of XSEDE standards. So level 2 has some of the similar services but doesn't have all of the similar services. Level 3 is essentially sort of advertising availability, and that you can work with folks at a level 3 center to get your code running up there. But it doesn't necessarily have it doesn't have XSEDE accounts and accounting. It doesn't have XSEDE, not necessarily have all the XSEDE software stack. So an example currently is the cyber infrastructure for the Open Ocean Observatory Initiative. We've also talked about other systems here at IU as level 2 and some level 3. I believe NC Gas is a level 3 service provider. Level 2? Oh, thanks, Bill. Yeah.
How is this connected with allocation? POP's allocation procedure?
It's not. The level 3 is not connected with allocation. And level 2 is it hooks in with allocation. So you're able to request an account via the allocation system. It needs to be able to interoperate. Okay. So one of the things that we've learned to sort of do within campus bridging, it's a new term. I keep saying it all through this talk. We need to set some expectations about what it is and what it can do. There isn't really a campus bridge. There isn't really a person who's a campus bridger the same way there's a campus champion. But what we can do is we can describe things as bridged. So it's really an understanding of how things need to technically interoperate. And we sort of need to make the case to XSEDE that campus bridging has special requirements. That these folks who want to interoperate need to have a little bit different access to resources, a little bit different policy, a little bit different documentation and training than the standard XSEDE user. And the other thing that we sort of need to do is make it clear to folks in XSEDE that not everybody wants to provide resources to XSEDE. Some people are just fine running their resources, and they want to have the option to scale up. They don't necessarily want to contribute cycles everywhere. So that's been a little bit of a challenge for what we've been trying to get done. So XSEDE, is set up as an organization to provide services and capabilities. And what the XSEDE team has done is collected a number of requirements from a number of different areas that it wants to support. And it takes these requirements, builds them into use case descriptions, creates these level 3 decomposition documents, and then it goes ahead and says we can write code that's based on this. And a lot of our time in the past year has been involved in creating these use case descriptions and working with the architecture team to produce level 3 decomposition documents that can then be used by the software teams. So this is sort of what a use case description looks like. You can see that we take something that's sort of very general. A user wants to make use of a machine in a certain way. And then we have to really break it down of sort of who's involved, what do you need to be able to provide this capability, what are the variants, what are the security implications, what are the quality attributes of this use case in terms of reliability, and then what are sort of policy concerns. So it's a fairly detailed process, and it takes a while to get through. The campus bridging team was sort of the first ones through the ordeal. We ran the gauntlet in the early part of this year and got our use cases in and sort of served as the trial team. There are a number of other teams that are currently in the pipe to go through the use case. And I think with every iteration, it gets easier and easier and easier. So what the XSEDE team for campus bridging was able to come up with in concert with the architecture team were 7 use cases with a general prerequisite. That was we needed to make sure that in-common authentication would be accessible everywhere. We wanted to come up with economies of scale and training and usability. We needed to make sure that users can access the systems via an interface that's comfortable to them. Probably the most important is an unedited slide. Is access to data, which previously I indicated we had a lot of our users wanted to know how to manage their data, to make use of distributed workflows, make use of computational facilities that we could share around, including like a co-op model where you could provide cycles in and later on draw them out the way you might think of as an agricultural co-op. And finally, access to resources just on, I need something right now, so I'm going to pay for cycles. And all of this has to be supported by unified trouble ticket handling that's going to be able to quickly get support issues to the responsible parties. So the economies of scale in training and documentation and usability that we're looking for are really to take, as I said before, take the best practices of XSEDE, take similar system templates, take guidance for installing software, in terms of just really like what does the system look like when you log on? Where are the things that you normally look for when you're going to conduct analyses? So that when you log onto a system, it becomes familiar to you, and provide a consistent way to set up a system that works on people's best experiences, and provide that to local system administrators. And they don't have to take on this system template. They don't have to implement this, but if they want to, then they can make use of that, and their users should see something that's very familiar to them when they start off with that and then move on to other resources. And I think we've learned a lot from the Open Science Grid model of the virtual data toolkit that provides a common set of things on any Open Science Grid machine. We want to sort of build on that knowledge and make it easier for people to find the familiar stuff. Working with the architecture group, we're developing installers for common tools. We find that if there's similar system layouts and similar software packages, we can take training and documentation that we've developed for that, and we can use that to apply in a lot more situations. So it's much more easier to just continue to reuse that documentation and training in different situations. It could be for XSEDE folks, it could be for regional, or just at a campus level. And the campus bridging team for year 2 of XSEDE will be putting together some Roxroll packages of software to distribute that make use of these standard templates. So as I mentioned before, the consistency in setups, and consistency in documentation and training allows us to reach a lot more people. It allows us to reach people at different levels, and we can really be a lot more efficient about how we can provide information, provide the software. So the goal in all this is to eventually create something that Craig has termed as a shared virtual compute facility. And this would be a virtual cluster that doesn't necessarily need to work with XSEDE. It provides tools that sort of look like it. We need to be able to support local authentication mechanisms. We need to be able to understand that not everyone wants to integrate with XSEDE necessarily. They want to sometimes build a resource that makes use of some of the resources, but not necessarily has to be part of the great collective. So jobs from XSEDE could be accepted at this shared virtual compute facility. That requires a trust relationship. That requires an ability to receive jobs. It requires trouble ticket exchange and sort of general policy agreements. But if this entity is created, this would be sort of a bridged resource where jobs can come in and come out and can be used. The XSEDE can be used to get the work done. The local resource can be used to get the work done, and it's pretty seamless to the actual researcher. Yes, Marlon?
Talk about some OSG services for
Yes, yeah. So I mean, the model is some of the breakthroughs that OSG has been able to do in getting campus resources that can accept jobs very easily and can join with the Open Science Grid. We definitely want to build on the example of that capability. So here's an example of a shared virtual compute resource where analyses take place on Cobalt and Popal. They write to IU's data capacitor. They're visualized at IU. others, MSU is not part of XSEDE, but it can contribute jobs and it can receive jobs in this. So the other big initiative that we've had in the past year is to work on a pilot program to test out the globally federated file system software, and this is part of the Genesis 2 package that Andrew Grimshaw's folks write. It's a globally federated file system that creates a single namespace that you can export data to. So data on your laptop can be visible on any XSEDE resource that's making use of the global federated file system. You don't have to do transfers and manage moving the data around. You do have to have a pretty good connection to the rest of the world from your campus. And we had a lot of interest on this when we first started the pilot. We've selected 4 pilot sites that are going to make use of the GFFS software. The details are on the slide about what each is going to do, and we have some really good examples of, Texas A&M is doing something really local. Kansas is doing something sort of regional. City University of New York wants to span all the way up to XSEDE. So we're able to sort of try this out at every level of getting stuff done. The pilot projects right now are working with XSEDE operations to make sure that the Genesis 2 software is meeting their needs as far as operational reliability and readiness. They're working on the distribution method for the software and certifications or certificates for security, and we're getting the users on to the XSEDE portal and adding them to the allocation, making sure that they have access to the global federated file system when it's in place. So at the end of XSEDE, what we're really looking at doing is having sort of an integrated national cyber infrastructure. XSEDE is part of that infrastructure, but it is not the infrastructure. And it's easy in this vision to have research that starts in your lab, in your community, and then it's possible to scale that up to national resources. XSEDE is going to be a critical component of this because it's going to provide a lot of the infrastructure, but it doesn't need to be part of any particular researcher's analysis. What we're looking at in the immediate future, there's a paper in the XSEDE12 proceedings which should be available really soon. The system descriptions are to be worked on in the first quarter of this program year, so before October, I think we're going to be working on that. I know Craig has a podcast in the works for getting information out to folks about campus bridging. We're going to continue work on the pilots and getting those folks able to access resources. We are working with folks at Cornell to create the first ROCS role, and we're taking input on what the ROCS roles will look like. We're going to continue working with Open Science Grid. We've had a really good partnership with Dan Frazier to talk about issues that they've run into previously and how we can work together. And in the final analysis, campus bridging is one single team within XSEDE, and we sort of all go into the hopper, and what XSEDE management chooses to put emphasis on, they choose, and we get to be a part, we get to address things at the priority that they set.
One question about the ROCS roles, but what's going to be the minimum useful amount of resources that one would need to have in order to install and use this?
That's a really good question. I think it's pretty minimal. I think we want it to be, I think we wanted to get it down to the level of a machine that you would use for a workstation or a laptop. Now that's a lot less capability, right? Depending on what you do. I think it's easier to get gateway capability into a laptop than it is to get some other computational capability into a laptop, right? Depending on the analysis. Right?
Getting somebody's code to work on that.
Yeah. So that'll be part of it. But I think we want to be able to address things from the researcher level, individual researcher in an office, and up.
Just one little, it might be useful also if you had this stack if we find if somebody using it finds a particular problem with it, to be able to communicate that back up the chain.
Yes, and that's a really important part of the campus bridging mission, is to gather requirements from folks who are interacting with that, and that's what'll come out of the pilot program that I was talking about earlier, is that the feedback from those projects is going to be fed into the Genesis 2 development cycle, so it'll actually affect what the developers at UVA are going to be doing with the software, and it will affect what the architecture team for XSEDE will be setting as targets. So we're able to actually get stuff back from campuses into the requirements process for that. And we'll do the same with response on ROX roles. I mean, it's very critical, and XSEDE management is very concerned with making sure that we get the feedback back into their formal requirements process. So we have 4 or 5 people involved with XSEDE, including myself from time to time, I guess, all working to put together the ROX roles, move the pilot project forward, get the word out, and talk with various different groups that are interested in campus bridging. And that's my overview.